Video automatic dubbing is a crucial task in computer vision, especially for dubbing videos with audible actions. Dubbing such videos often requires algorithms to localize sounding frames along the temporal dimension. Given new audio source and temporal position of sounding frames, we can automatically dub the original silent video. Techniques related to detecting specific temporal location of audible actions in a video remain unexplored. One of the most related fields is video action recognition. The corresponding methods focus on identifying different types of actions within a video but often miss the crucial spatiotemporal dynamics surrounding specific motion frames. Besides, methods for temporal action localization have shown powerful capabilities in quantifying the categories and boundaries offset of actions. However, they predominantly focus on the relationships between actions rather than their specific kinematic characteristics, resulting in a poor attention to the unique properties of audible moments. In this paper, we delve into this and formally present a new task of audible action temporal localization, aimed at predicting the frame-level positions of visible audible actions. Our contributions can be concluded as follow. Considering the lack of specific labels for audible actions in existing video action datasets, we created a new dataset named Audible 623, which comprises 623 videos with collision sound actions, with audible actions marked at the frame level and an average of 250 frames per video. Moreover, we propose a strong baseline called TA²net, which utilizes both spatiotemporal dynamics and kinematics analysis for temporally localizing audible actions. Our fundamental assumption posits that audible actions, specifically collisions, are typically induced by sudden changes in the forces acting upon an object, which manifest as inflections in velocity. Additionally, these collisions are the primary sources of sound. According to this, we delve into the velocity inflection and motion in both temporal and spatial perspective. For temporal modeling, we propose the concept of inflectional flow to signify sudden changes in velocity of an object, enhancing traditional kinematic analysis by serving as a motion prior. For spatial modeling, we introduce a self-supervised auxiliary training strategy, constraining the prediction of audible actions through both inter- and intra-video view. Here is our overview. Given the video sequence as input, we first conduct the kinematics analysis to calculate the proposed inflectional flow as one of the kinematics priors under the sound from collision assumption. The kinematics analysis provides a crucial collision prior according to the motion flow estimated by optical flow particularly. The light parts in magnitude map of collision flow illustrate the momentary change in the direction of motion. The details of these parts can be found in the main paper. Then 3 separate encoders and a cross-kinematic aggregation module are introduced for extracting contexture feature and popping up motion and collision information. To further model motion and velocity inflection in the spatial dimension, we utilize a self-supervised spatial auxiliary training strategy to localize the motion of the object, both at intervideo level and intravideo level, constrained by the contrastive loss and the smoothness loss, respectively. We then learn classification probabilities which indicate frames containing audible actions using a supervised classification loss. Here we show some visualization comparisons of temporal probabilities prediction. Our model achieves better performance comparing to baselines in both accuracy and completeness. Furthermore, we extend our method to repetitive counting task. Our method achieves top 2 performance among the compared methods. We also show some visualization of spatial localization results. Our method can effectively localize the motion spatially without specific training. We further show some results on video redubbing as a key application to fully exploit our model.